Can we skip 2 forward? One more? Yes? Yeah. Okay, this is it. Thank you.
Okay.
Okay, so all the studies of individual differences in autistic traits that have been done using twins so far were all either in children or in adolescents. No studies have been done in adults. And at the same time, it's still unclear what the role is of assortative mating. Assortative mating is non-random partner choice, so people either actively or passively choosing their partners for their autistic traits. If they do so and they choose them similar to who they are themselves, then there would be a positive correlation for autistic traits between spouses. And this idea of assortative mating playing a role in autistic traits has been hypothesized to affect the risk for autism, and it would also bias findings from twin studies. Previous studies that have looked at assortative mating for autistic traits have been inconclusive. Some studies have been done in general population samples looking at autistic traits, and Constantino and Todd suggested a substantial spouse correlation for autistic traits of 0.38, but then 2 other general population samples suggested a non-significant correlation for autistic traits between husbands and wives. 2 other studies have been done in parents of a child with autism, and these again suggested significant correlations of around 0.3. So it's still unclear what the role is of assortative mating for autistic traits. So in this study, I wanted to look at the heritability of autistic traits in an adult sample and look at the assortative mating. And for this, I used an extended twin family study. Rather than just studying the twins, we also asked the spouses, the children of the twins, and the parents of the twins to fill out the questionnaire. And this particular design is very powerful to examine assortative mating. I will explain later on why that is. We asked twin families who are registered at the Netherlands Twin Register to participate. 305 twin pairs participated with a mean age of 46 years old. And we also asked their spouses, their siblings, their parents, and their children. And in total, over 1,000 people participated. And we asked all of them to fill out a short version of the autism spectrum quotient. This is a self-report measure of autistic traits. The full version of the AQ includes 50 items. This short version includes 28 items. And example items are, I prefer to do things with others rather than on my own. If you definitely disagree with that statement, that would be in line with autism, scoring 4 points. I like to collect information about categories of things. If you definitely agree with that statement, that would be in line with autism. So in this case, the scoring would be reversed, giving 4 points for a definitely agree answer, leading to a minimum of 28 and a maximum of 112. Thomas Bougeron already showed the full scale AQ distribution. This is the distribution for the AQ short. You see 3 control samples here, 2 samples from Holland and 1 sample from the UK. So you can see that there's considerable variation in AQ short scores in the general population. And here is a sample of people from England with an Asperger's syndrome diagnosis. So they clearly score at the extreme end, although there's again also considerable variation within the Asperger's syndrome group. In the classical twin design, we compare the resemblance of identical twins on a trait with the resemblance in non-identical twins. Identical twins are genetically identical, non-identical twins share on average 50% of their genes. So if identical twins resemble each other much more closely on autistic traits than non-identical twins do, then that gives an indication that genetic effects must be important for autistic traits. So this is the theory, the idea behind the classical twin design. In this study, apart from the twins, we also included the spouses, the sibs, the parents, and the children of the twins. And there should now soon be a family tree. Okay, thanks. Here is the family tree with the twins and their siblings. Sorry, the siblings over there. Here are the spouses of the twins, if they are available. If available, the sibling would participate with the spouse of the sibling. Here are the parents of the twins and the children of the twins. This is a family, an ideal family tree spanning 3 generations. In our case, we either had data of the twins and their parents or of the twins and their children. So there were no families that spanned all 3 generations. And this type of design is really good if you want to examine assortative mating. Assortative mating, you would look at the spousal correlation, but in this particular design, we don't just look at the spousal correlation, so for instance the correlation between the first twin with their spouse, but also at the correlation between this spouse with the co-twin, or this spouse with the other sibling. And you can also look at the correlation between the spouse and the spouse of the co-twin, or the spouse and the spouse of the sibling. So this gives us much more information, and it also makes it possible to look at possible models that explain assortative mating. If there is assortative mating, why is it there? Is it because of social homogamy? Do people grow up in a similar cultural background? And does that explain why they resemble each other on autistic traits? And this is suggested when all the correlations that I just showed, so all the spouse or spouse co-twin correlations are similar. Or is it due to phenotypic assortment? Do people actively select their partner based on observable autistic traits? And this is suggested when the spouse MZ co-twin correlation is higher than the spouse DZ co-twin correlation. Apart from tests of assortative mating and tests of how important are genetic effects or environmental effects, this extended twin design can also look at dominance effects, effects that are shared environmental effects that are specific to the twins or specific to that generation of twins and their siblings. And it can look at shared environmental effects that are shared by the whole family, so both by the parents and their children. And because this is a type of effect where the shared environment is transmitted from the parent to the children, it's often called cultural transmission. But in this particular design, we have a lot of family relations to specify, and although there were nearly 1,100 participants, that is too limited to then also separate effects for the different genders and for the different generations. So the analysis that I'm presenting here today were combined for both genders and for all generations. Here you see the twin family correlations. In dark blue, the correlations for identical twins. And you can see that those are substantially higher than all the other family relations of people who share less genetic information. And you particularly see the difference between identical and non-identical twins, suggesting genetic influences on autistic traits. The estimate for non-identical twins and sibling correlations is somewhat higher than the correlation between parents and their children. Both share 50% of their additive genetic effects. So this is somewhat remarkable, and I'll come back to that later. Here in brown, you see the correlation between the spouses, and this correlation is only modest, and the other correlations between spouses and co-twins are not even significant, suggesting that if there is assortative mating, it's a very limited effect. We fitted all these different family relations in structural equation modeling. I won't really go into details of this path diagram, but in case there are other structural equation modeling fans, you may like it. I've only shown it here for the parents of the twins and for the twin pair, but the real model was also fitted for the siblings, for the spouses, and the children of the twins. We found that genetic effects explain most of the variance, 55% of the variance. Non-shared environmental effects explained most of the remainder of the variance, 41%. And this particular type of variation also includes measurement error, so it's not just unique environmental influences. And then there was a significant effect of cultural transmission, very small effect, 4%, and a tiny effect of assortative mating. And there were no significant effects of dominance or twin-specific or generation-specific shared environmental influences. Although at first that cultural transmission looked interesting, a closer look at the parameter estimates showed that this cultural transmission factor, here shown by an F, although it's a little bit small, this factor is negative. And if there is a consistent social background that makes parents and their children more alike, you would expect that pathway to be positive. So rather than it being a consistent social environment that is shared between twins, siblings, spouses and parents, it seems that this parameter mainly reflects the relatively low parent-child correlation compared to the non-identical twin correlation and the sib correlation. And this could potentially be due because there are different genetic influences in different phases of adulthood. And unfortunately, this sample was too small to look at these generational differences in heritability. So it would be interesting if future large-scale studies could look at these age-related changes in heritability over the adult lifespan. It would also be interesting if those studies could look at sex differences, because again, this study was underpowered to look at that. So this study suggested only a very limited effect of assortative mating. That is in contrast to some of the previous studies that used the SRS, the Social Responsiveness Scale, which is a spousal report measure of autistic traits. Using that measure, both in general population samples and in clinical samples, they found a significant spousal correlation. And the measures using the AQ found non-significant or only very small correlation between spouses. Well, how come, what can account for these differences? The SRS is a spousal report, and it might be, so it's the husband reporting on the autistic traits of his wife and vice versa. And it might be that that correlation is inflated because of some shared perception of their relationship. The study by Pullman didn't just study the AQ in newlywed couples, but also asked them to fill out questions about relationship satisfaction, relationship intimacy, and partner trust. And she did find significant correlations for that in the spouses. So it might be that the SRS mainly picks up, or somewhat picks up, perceptions about relationship satisfaction or relationship intimacy, rather than really assortative mating for autistic traits. Alternatively, it might be that a self-report measure of autistic traits underestimates assortative mating. So perhaps the truth lies somewhere in the middle. So to conclude, this study showed that autistic traits are substantially heritable in adulthood, with a heritability of around 55%. And this suggests that autism gene finding studies may be aided in using such a quantitative assessment of autistic traits. This has already been done, for instance, by Bishmadev Chakrabarty et al. In a candidate gene study using the AQ, and also in a study by Duval, who used the SRS and found significant linkage using this quantitative approach. This study also suggests that assortative mating effects are limited and as such unlikely to be a big effect on autism risk. I'd like to finish with thanking my co-authors Annabel Vinkhuizen, Sophie van der Sluis, Danielle Postuma and Hermine Maas, all the twins and families that participated in the study, and financial support. Thank you.
Thank you.